Hello, good morning, everybody, and welcome to the Temporal Meetup. We have a cool agenda for you today. However, we have one adjustment. Unfortunately, 1 hour ago, we got note that our colleague from Smart Recruiters will not be able to make it for personal reasons. However, they will present next month, so we already have a great talk queued up for you next month. But yes, so today we'll cut a few minutes short. I am sincerely sorry for that, sincerely apologize, because I understand all of you put 1 hour aside, but was an unexpected circumstance that came up this morning. So we're gonna jump over Smart Recruiters, delay that for 1 month, and we immediately come to Patrick this morning. Patrick, who works at Douglas, and will tell us about their experience with Temporal. So thank you very much, Patrick, and please take it away.
Thank you very much. Just a second. So today I will show you how we're using Temporal at Douglas, and how we're doing that for scaling to a revenue beyond of 1 billion euro revenue per year with more than 20 development teams. So a quick introduction of myself. I'm a software architect at Netconomy, so feel free also to reach out to me if you have any question afterwards. At Netconomy, we are doing some e-commerce solutions and cloud-native application development, and for that, Temporal really suits very well. And together with Douglas, we are building their e-commerce platform. So if you haven't heard of Douglas, Douglas is a beauty and health retailer in Europe. They are operating in 19 countries. They have physical stores, but also an online platform in all of those countries. So the title of the presentation admittedly sounds a bit like a clickbait, but it's really true that we have more than 20 engineering teams. And also the online platform is driving a revenue of more than 1 billion euro per year already, and possibly this would also grow in the future. But as you can imagine, at that scale, there also come some challenges. So the first type of challenge lies in the area of resources. So to generate that revenue, as you can imagine, a lot of orders have to be placed. And during peak times, when there are some promotions, that can mean currently already up to 25,000 orders per hour or even more. But it's not just compute resources, it's also storage, which is bringing us problems, because every order that is being placed also needs to be stored somewhere. And with the existing database that we are using for the monolithic application, which is at the core of our platform, there is a hard limit of 4 terabytes. So even a bigger even more money would not be able to buy us a bigger database. So we need to come up, or we did need to come up with a solution for that as well. But there are not just challenges in the area of resources. With that development setup with more than 20 teams, as you can imagine, there are also some challenges in the area of the software development lifecycle, because that 3-digit number of developers is working on a common code base. And at least for this central application, which I will show you later a bit in more detail, there are quite big deployments which take up some time. That's why, and also some organizational efforts, which is why we deploy this monolithic core application only every 2 weeks. And yeah, now that you have an overview of the challenges, we asked us the question, how can we do it better? How can we come up with a better solution? So the scope of my presentation is, as you might already have guessed, it's order management. So order management covers everything after the checkout until an order arrives at your doorstep. So in simple terms, order management or an order process is starting when an order is placed after the checkout has been completed. Then usually during an order process, in some way or another, usually a fulfillment department is involved to pack your order, to send it, and hopefully, in the very most case, the order is delivered to your doorstep and ends with a happy customer. So now you have an idea of what order management means. But how does order management look like in practice? For a small shop, it could be as simple as just sending an email to the fulfillment department, and that fulfillment department takes care that the order is sent. But in the case of the Douglas platform, it looks a bit more complicated. So what you see on that picture is a visualization of the existing order process, so everything that happens after an order has been placed. It's not intended to be readable, it's more just for visualization of the scope and complexity of such a process. So really a lot of systems are involved after an order has been placed. So it could be something like payment related, one of those boxes. It can also be fraud check related, or it can be related to fulfillment. All of those things are somewhere within such of a process. But how were such processes executed in the past? For that, I will not take the real world example, but I will take a simplified example to not use up the full hour or even more. So let me show you here a simplified example of such an order process. So here we just have a couple of steps like a fraud check, export to some third-party system, export to logistics to make sure that the order gets shipped, and then the process is done. But how was such a process orchestrated previously, before we had Temporal? So one important thing to mention here is that previously the whole orchestration of business processes was happening within SAP Commerce Cloud, which is this big monolithic application at the core of our platform that I've mentioned. And so here the task engine would define, okay, first when a new order is placed, the fraud check would need to happen. Then, for example, export to third-party system, and then at the end, export to logistics in this simplified process. So even if we already were using microservices since the beginning of time, I would say, we still had the problem that the orchestration was done with this monolithic application in the core. And this Commerce Cloud application is a quite heavyweight application, so we cannot deploy it arbitrarily often. I've mentioned we only deploy every 2 weeks if there is no good reason to deploy more often. So yeah, just you see here, after an order has been placed, if it would be no fraud, then it would be exported to third-party system, exported to logistics, then the process was done. But yeah, having the challenges in mind with that high compute resource usage due to the many orders that are being placed, and with the database hard limit of 4 terabytes, and also the challenges in the software development lifecycle, we were some time ago sitting together and thinking, okay, what would be a better solution? So what would be the ideal solution for our problem so that we can scale even further and that we can work in the setup as we have it. So we defined a vision, and in that vision, we defined that order processing should happen completely outside of commerce. We also said it's important that the solution is fully horizontal scalable, because maybe one day we don't need to be able to process 25,000 orders per hour, but maybe 50,000 orders, or who knows, even more. And we also said, besides of those constraints, the new solution should be appropriate for a large-scale engineering team. So how can we get to that new solution? We started to draft a migration journey to get to this target architecture. So keep in mind that the financial success is depending on order processing, which made it very important for us to reduce all the risks, or as many risks as possible, for migrating to the new solution, which, as you might already have guessed, is Temporal. So the first step of the migration is to extract the orchestration. As you've seen, initially orchestration was done with the task engine within Commerce Cloud. And we said the first step to move to Temporal is to extract the task engine or to replace the task engine with some form of distributed workflow platform, which is in our case now Temporal, while still keeping all the business logic, the existing one in Commerce Cloud. The reason for that is because there already exists a lot of logic in Commerce Cloud, and it's not possible to rewrite everything from one day to another. So with that approach, we were able to first introduce Temporal as orchestrator while still keeping all the existing logic, because we just need to implement different interfaces. So what does that mean in Temporal terms? For Temporal, that means that we implement the existing business logic as activities in Commerce Cloud. So Commerce Cloud also acts as a worker in the Temporal cluster. And we introduced or started just with one microservice, which only is running the workflows, in that case, the order workflow. So with that, we already have the definition of the process or of a workflow. We can already deploy independently of Commerce Cloud. We also can independently scale, for example, this order management service. And we also already can offload some of the load from Commerce Cloud, which was hosting the task engine, to Temporal. So with that, we did already gain some things. But also for that phase one, we were thinking, okay, how can we make this transition as smooth as possible? So for that, at the beginning, we were also sitting together and looked at all of the existing business processes, because there are multiple of them. So there is just one, the order process, which is executed once an new order is placed. But there are also others, like, for example, if an order has been canceled, the product has been returned, and so on. There are really lots of processes as part of this whole order management system. So we looked at all of those processes. We checked, okay, what would be the advantage when we replace the task engine here with Temporal, that we have here the orchestration. But we also looked for each of those processes, how high would be the risk when we do that? And then we identified a group of processes or workflows, which I, by the way, use as synonyms in that presentation. And we started with the processes which have a low risk and a high benefit when we migrate them to Temporal. So we did not just roll out the processes gradually, process by process, but we also, for enabling a new process or going live with a new workflow in Temporal, we didn't just fully switch it for all of the countries, for all of the 19 countries, but also there we decided to just slowly enable the feature flag just for some countries or just for a portion of the users to get first production experience, and also to start with the smaller countries. And then later on, once all of the bugs were found, to continue rolling out completely with one process, and then continue with the next one, and so on. So with that, I think we have found a good approach to avoid or to reduce the risk for changing the orchestration from the task engine to Temporal. But of course, the migration journey doesn't end here. Also, what is still on our roadmap is we also want to get the individual steps of such a process outside of Commerce Cloud into a microservice architecture. So this phase 2 means that we extract all of the individual workflow steps, which were previously in Commerce Cloud, and put them into different microservices, which then can be scaled independently, and also which can be developed and deployed by different teams. So they can manage their own software development lifecycle. They can decide on the frequency of how often they want to roll out the change in their services, and so on. But also for this phase 2, this is, of course, takes some time. And for that, we also thought, how can we approach this in the best way to avoid unnecessary risks. So you might already have heard of the strangler pattern. A strangler pattern is used to migrate from legacy applications to more modern applications. And we took this idea and applied it to Temporal, and yeah, which I will show you then in the upcoming slides. But the high level idea is just that you gradually replace some legacy system with and move the logic to a modern system, and that the strangler facade is pointing to the to the implementation either in the legacy or in the modern system. And at the end of the migration, then you would have everything in this modern architecture. Yeah, for our scenario, this strangler facade would be the temporal workflow. The legacy system would mean that we have activities in Commerce Cloud, and the modern system would mean that we have the activities in a microservice architecture. So if we look at this applied, the starting position again would be all of the activities in Commerce Cloud. Then later we start to extract the first piece of logic or the first activity from Commerce Cloud into a microservice. And this we continue and repeat until we end up with having everything in a microservice architecture. So then the journey would be completed. And yeah, just for completeness, in temporal terms, that would mean here the activities are here also in only microservice architecture. And the workflow, as you already saw from the beginning of the migration, is running in this order management service. And then we're done. So let's now have a look if our challenges are solved with that approach. You remember from the beginning the challenge with the high throughput or with the compute resource usage, with the ever-growing database, and also with the large-scale engineering team. So let's start with the compute resource challenges. So we said we want to be able to, or we need to be able to at least process those 25,000 orders per hour, what we already were doing before, and possibly even beyond that, maybe 50,000 someday. So the solution to that can only be full horizontal scalability. And this is achievable with a microservice architecture. If you do the microservices right, then typically they are horizontal scalable. So you could have multiple instances of service A, and you can also independently scale service B. So with a microservice architecture, horizontal scalability is definitely achievable. And luckily, Temporal is also horizontal scalable by design. So let's now continue with the storage challenges. You remember that previously every order was ending up in this database, which belongs to Commerce Cloud, which had this hard limit of 4 terabytes. So the solution to that can only be to get the database or the orders outside of Commerce and store them in a dedicated database. For example, that is here belonging to microservice A. And also you would have the advantage that you can have even multiple databases, because if you think about our e-commerce approach or e-commerce use case, not every microservice needs the same view on the order. For example, for fulfillment, you're more interested in the different positions, what was ordered, how many items, what is the shipping address, the delivery address, and so on. Whereas if you think about payment, there you don't actually are that much interested in the items, but you're more interested in how much did it cost, what was the payment method, what are the payment transactions, and so on. So with that, you can even split up the data into different business domains, and it can be owned by the different services. And also last but not least, before we had transactional relational database, and this you could then also replace with a NoSQL database, which has better scalability. So with that, the storage challenge is also, we can also handle that. And then last but not least, the software development lifecycle, because you remember with the deployments that they involve some effort, and that's really lots of teams are working on the same project together. And the solution to that is with microservices, we can now have continuous integration, continuous deployment. We can deploy fast every microservice. We can deploy them independently. And also the teams can on their own decide when they want to deploy. So the deployment problem is with that resolved. The second problem is also solved with the many teams, because with microservices, we can have now ownership on team level. So each sub-team could own a different microservice or a set of microservices, or also some, for example, just some child workflows, which are part of a bigger workflow. And yeah, with that, you could have like a payments team, which is working on the payment service, and a fraud checking team, which is working, for example, on the fraud service. So now at the end of my presentation, let's have a look if this vision is achieved with our solution. So we said that order processing should be done completely outside of commerce, which is the case because with Temporal, we have the orchestration outside of commerce. And we also are now on the way to get all of the logic outside of commerce into microservice architecture and to store the different and to store the order only outside of commerce. We also said that the solution should be fully horizontal scalable, which is also the case with both Temporal and the microservices being horizontal scalable. And we said that the solution should be appropriate for a large-scale engineering team, which also is the case because the different microservices and child workflows can be managed by the different development teams. Yeah, and with that, I'm at the end of my presentation. So if you have any questions, please let me know.
Awesome. That was a fantastic presentation, Patrick. Thank you very much. We have a few questions in the chat. Let's start with Gregory's question first. They're asking what makes a particular process having high benefit, referring to the risk-benefit chart.
I mean, for example, we have like email processes, like just generating an email and sending an email. You could look at it, that's okay, getting that to Temporal, you have already a high benefit in terms of resource usage or to reduce the resource usage within Commerce Cloud because there are really lots of those processes. And they're also easy to get out. So with that, you would have a high benefit. But we didn't just look at that. We also said, yeah, maybe we don't just want to start with something too simple, but we also want to have more like a real business process, which also has a bit more complicated business logic. And yeah, because of that, what we did is we started with the return process. I think I forgot to mention it because if you think about it, not every order is being returned, luckily, only a small percentage of them. So if you have some bug in it, in the returns, then the impact is not so big and it's easier for you to fix it and to repair everything than if it would, for example, affect every order. So with that, we said, yeah, with the return processes, we have the benefit, not just that about the resource consumption, but also the benefit would be that we already can get some production experience before moving on with the next process, which is maybe slightly more complicated, but there are just lots more of them. Yeah.
Smart. Babu was asking, where do you hold the state of the order and how do you transition the schema data during the cutover?
Yeah, so we are currently still in the process of doing that. But the idea is that, right now we still have orders in commerce in this phase one where we still have all the business logic in commerce. So we thought, okay, we at some point we start after placing the order to store the order in some database outside of commerce, and then later on, if you, for example, get a return for this order, you would check, okay, does the order exist in this new database outside of commerce? In that case, you would need to process it like that. Otherwise, you would need to process it with the database in Commerce. So we did not yet have planned to migrate the old data to the new system, but just every new order that is being placed then will directly be persisted outside of Commerce. That's the idea. And about the old orders, we can also think about maybe migrating them in some other kind of storage. So that's also on our roadmap.
I guess that is almost an answer to Christian's question as well, who asked what role does Commerce Cloud play after this migration? Does it still have a record of orders?
So Commerce Cloud will not play such a big role anymore in processing the orders. I mean, ideally no role anymore at all. But Commerce Cloud also has other features where it is good, like maintaining the inventory of products and like as a PIM system, for example, also the whole checkout could also still remain in Commerce. So it's more like the system to generate the orders. But once the orders are generated or the checkout is completed, the whole other processing can then happen asynchronously in the background. Yeah.
Alif asked an interesting question, and that is, in a NoSQL database, an activity result could trigger multiple table updates, even within the same microservice. If you faced that, how did you minimize that chattiness, multiple activities required just to updates to achieve data consistency?
Yeah, I mean, we are not that far yet with that part, so I would still need to think about that, to be honest.
Yeah, very fair answer. And then for the last question, Babu asked, did you have a high-level workflow defined that's child-level workflows, or the entire forward return journey was a single workflow?
So for this order workflow, which is executed after placing a new order, we at least identified some child workflows. For example, for payment-related things, there is lots of logic. It's not just one activity. Those are more or less executed together if you look at the timely execution. So there it made sense to put it into a different child workflow. And also then we can run this not just in this order management service, but we can then directly run this child workflow in a different service, in the payment service, and that it's then fully in control of the payment team. But we also have like activities on this bigger order workflow outside. So it's not that we have a big workflow which is only calling child workflows, but we have activities on both level of abstraction. And like we identified payment, for example, as one child workflow, we also had the other area, which is fraud checking, which also involves multiple strategies how to check if an order is fraudulent or not. And that's also implemented in one child workflow.
Since more questions are actually coming in, but we do need to move along. We had a little more time today to answer questions because we were one presentation short. But Patrick, if you could, maybe you can answer some of the questions as they come in the chat, and then we move on to the second presentation. Thanks again. That was really fantastic. Thank you very much. Great insights.
Thank you.
So for the next presentation, I am actually switching my role here from host to presenter. So that presentation will be on me, and we will talk about a topic that I am very passionate about when it comes to Temporal, and that is handling failures from first principles with Temporal. And Temporal has some amazing failure handling qualities, and I would like you to think about this presentation with one statement in mind, and that is that the current best practices, they prefer backwards recover. The current best practices prefer that if we encounter a failure, we will stop the business process and try to roll the business process back to achieve consistency. But that means, of course, that we abandon that particular business process. But with temporal, it is beneficial to think about the world differently. And that is, think about forward recovery. With a temporal, if your process encounters a failure, you should prefer to actually fix the underlying cause of that failure and then make forward recovery, because then you still transition your system into a consistent state, but you are actually executing the business process. So keep that little preview in mind, the TLDR, that is the overarching theme of this entire presentation. Now, at some point, I will figure out how to actually share a keynote full screen presentation on Zoom, but that is not today. So unfortunately, we are all stuck with this little hybrid view here. But I would like to direct your attention to the bottom of the screen. Sometimes there will be a temporal logo. So when you see that temporal logo at the bottom of the screen, that is that indicates that something is a little bit more temporal specific, and any other slide that doesn't have that logo is a little more like a general foundational. So first off, when we talk about processes, right? So we to define what actually is a process, and in this for this presentation, we will take a very simple point of view onto the world and say a process is a sequence of steps. And oftentimes these steps are called tasks. These steps are called actions. But of course, as we know in the context of temporal, that process is often called a workflow, and the actions are often called activities, or not often, they are. So we are talking, while we are talking processes and actions in the world of temporal, we talk about workflows and activities. And we will take, again, an e-commerce workflow, very simple one, e-commerce workflow. We don't even like look into the details. Just keep in mind, we have one action in there, one activity in there, a charge activity that charges the customer for whatever the customer ordered. Now, the charge activity for our example, the charge activity may throw two exceptions, an insufficient funds exception and a connection exception. And it's important to realize here, for this example, there are no further details. All right, the connection exception doesn't tell us anything why the connection couldn't be established or why the connection was severed. All we know is we had a connection exception. Same is true for insufficient funds exception, whereas that is a little more self-explanatory. There is probably not too much more information to it. Okay, now let's dive into failure handling. So failure handling is universally consists of two different activities, and that is failure detection. We need to figure out that a failure happened, and failure mitigation. After we figured out that a failure happened, we need to deal with it. So we will not focus much on failure detection, but let me say that failure detection is actually a fairly difficult undertaking. So in our non-distributed world, right, we are basically used to dealing mostly with exceptions and exception handlers. And if the underlying node actually crashes, the entire process disappears. But in a distributed world, that is much more complex. Of course, we still have exceptions to deal with, but also timeouts, because the absence of a message does not necessarily mean that the process that was supposed to send the message is actually gone. It may only be slow. So this is in itself a very tricky part. Many different algorithms are designed or devised for this. And let me just point out that Temporal already implements all of this on a platform level, right? So Temporal implements hard beating and timeouts and of course exception management on a platform level. So the failure detection part is already taken care of. So this is already a big leap forward in the context of distributed systems. But for this presentation, we want to focus more on failure mitigation. Now, failure mitigation, as I said previously, can be split in forward recovery and backward recovery. So when a failure happens, forward recovery refers to the fact that we repair the underlying cause of the failure and then make forward progress. So that is, we do not abandon the process. We fix the process and then run the process to completion. Whereas in backward recovery, when a failure happens, we roll back the changes, or we compensate for the changes that already happened in order to achieve consistency. Now, backward recovery has the benefit that it most of the time does not require repair, right? So all we're doing is we're basically taking steps back. But we should realize business processes are the value generating entities of our business, right? So then if we do a back of the envelope calculation, we generate more value the more business processes we execute to completion. So from that point of view, forward recovery is preferred from backward recovery because that doesn't run the business process to completion. That basically makes it look like that business process was never invoked in the first place. Now, backward recovery is the more dominant method because it's the simpler method if you do not have something like temporal. But with temporal, forward recovery does become feasible and achievable. So in order to deal with failures, we need to classify failures. And we can classify failures on two different dimensions. We can classify the failure on a spatial dimension, or we can classify failures on a temporal, well, the timeliness, temporal classification. I will not try temporal classification on a temporal dimension. So let's look at the spatial dimension first, the spatial classification. There are application level failures and platform level failures. Now, what does that mean? Application level failures means that the layer that we can completely and correctly mitigate a failure is the application level. Whereas platform level means that a failure where we can completely and correctly mitigate a failure is the platform level. In that case, this is transparent to the application level. The application level doesn't even know that failure happened. Now, for our example, insufficient funds is clearly an application level exception, right? That is an exception in the business logic. The platform, no matter what platform, can never mitigate that failure, right? From the point of view of temporal, an insufficient funds exception is meaningless. Now, a connection exception is different. That is indeed a platform level exception. The platform may be able to mitigate that exception via retries completely transparent to the application. Now, before we get into the details, we also want to look at the temporal classification of a failure. What types of failures are there on the temporal dimension? So there we can split failures into different groups: transient failures, intermittent failures, and permanent failures. By definition, a transient failure is a failure that repairs itself. It is here and it will go away. So it's classified as an auto repair failure. An intermittent failure is also a failure that repairs itself. It is here, sticks around for a while, it will go away. So again, auto repair. However, permanent failure by definition is a failure that requires manual repair in order to overcome that particular failure. So when we look at the individual definition for a transient failure, the failures can be expressed in probabilities or likelihood. So for a transient failure, the likelihood of a failure occurring again just because a failure occurred previously is unaffected. It is not elevated. For example, if our connection exception was caused by for example, a restarting router. A router was restarted, and somewhere in the chain of TCP connection, router was restarted, so that connection dropped. What are we going to do? We immediately fire that connection back up because it is not. It will find an alternative path. The likelihood of that to happen right away is not elevated. Now that is different from intermittent, where the likelihood of a failure reappearing if it just appeared in the past interval is elevated. Now that would be an example. Would be a routing table that is out of sync and needs to be synced. And that may actually take a while, or for example, DNS records needing synchronization, that may take for a while. So if that failure hits, there is the likelihood is elevated that if you retry that right away, that it will fail again. And permanent is if the failure happened previously, it will happen again with a 100% chance. Good example is an expired certificate. Once that certificate expires, right, it stays expired. So this is a permanent failure situation, and it needs manual repair. Somebody needs to go somewhere and fix that certificate. Okay. So then, how do we put all of this together? First question is then, how do we mitigate application level failure? Application level failure needs to be mitigated on an application level. You need to actually write code to mitigate that failure. And application level mitigation often still requires backward recovery, compensating action. Because, for example, in our e-commerce, could you retry, right? Insufficient funds. Could you retry once every hour for a day to charge that credit card? You could, but we usually do not do that. We accept that insufficient funds is a permanent error, and we roll back whatever we did, or sorry, not necessarily roll back. We compensate whatever we did before we trying to charge the credit card of the customer. However, there may be other strategies. If it's a customer in good standing, you may give the customer credit. You may actually try for a while to get that payment, send out an email, fix it on application level. However, there is code involved that is not transparent to the application level whatsoever. There is actually business logic. Now, mitigating platform level failure, like for example, the connection failure, that is interesting because we can actually apply, and we should apply, forward recovery, and temporal makes that much easier for you. So, for example, when a failure hits, like a failure connection exception, remember, we don't know anything else about that failure. We just know that it's a connection exception. We will assume that's a platform level failure. It's it's transient. We just assume that it's transient, so it auto repair failure. Because we assume it's transient, we retry right away. If it's a success, it's a success. Wonderful. We make forward progress. Well, if it's not, then we need to upgrade our understanding of that failure. We upgrade the understanding, and now we say, okay, still a platform level failure, but it's intermittent. Yeah, the next worst part, and still auto repair. So now we're retrying with a back off to give it a little bit more time and try to jump out of that interval. So if it works, it works, wonderful. If it doesn't work, we retry that for a few times, giving the caller more and more time to auto repair itself. That doesn't work. We once again have to upgrade our understanding, and we now say, okay, this is a platform level failure, but it's a permanent failure. It will require manual repair. So at this point in time, somebody actually has to go into the system. For example, we figured out, man, expired certificate happens to the best of us. So we need to update that certificate to make progress. Well, that doesn't work. We still have the option to retry a few times. If it works, we are good. If it doesn't work, we have the option to retry a few times. But eventually, there is usually a timeout, right? There's a timeout on a business logic level where we say we try for half an hour, 1 hour, whatever your business allows, to collect that payment. And if we cannot, we cannot. At that point, we need to elevate that failure. That is, we actually present it to the application level. We can say we did everything we could. On a platform level, we try to handle that failure transparently to your application, but now at this point we have to give up. We ran out of time, and now application, you have to deal with it. And again, we could say, okay, now we roll back the changes, or we check if the customer's in good standing, give them credit. So then eventually the application can decide, all right, I got this, with applying, for example, yes, good credit, or good standing, or we say something like, yeah, okay, this is a permanent failure, there's nothing we can do about it, and roll back the application to have consistency. Now, for Temporal, how can Temporal help you, or how should you think about Temporal? For Temporal, we talk a lot about retry policies, and we talk a lot about timeouts, but these are not their configuration. Okay, these are, I'm sorry for that. I'm sorry, my coworker. So these are not mere configurations. These are indeed your strategies, how to handle errors. And as an example, for our connection example, we can with the right strategy say, okay, this is a transient failure, but then we enter a time where we say this is an intermittent failure, giving the correct back-off interval back-off coefficient. But then eventually we say, okay, now we need to handle that failure as a permanent failure, and we start idling around that failure. That is what you see here in blue. We start idling around that failure where we assume it's a permanent failure. And we have now time until the activity times out overall. We now have time to fix the problem, like, for example, go back into the system, update the certificate, and then the next time Temporal will retry, we can make forward progress again. So this is not a mere configuration. It is an actual possibility to fine-tune your failure handling strategy for your workflows and maximize the chance of success. There, I would like to highlight one super cool feature that we have in the documentation, that is the activity retry simulator. With that, you can graphically see how to fine-tune your activity retry strategy to best go through the motions of what is considered transient, what is considered intermittent, when is it considered permanent, and how much time do I actually want to give my overall activity. And then lastly, we have a lot of material for the failure handling up. One is a blog post that will cover this material, what we did today, that I released on the weekend. So I just posted the tweet on the chat. So if you want and like and retweet, that would be much appreciated. But we also have more material coming. We have one blog post of my colleague Fitz. I self-admittedly have a very dry writing style, yeah. So it's like you may want to read this despite the fact that I wrote it, but Fitz has very fun writing style, so you may prefer his blog post. And we also have more material coming up. The next one is an interview between Tom and me, where we also dive deeper into the failure handling. Okay, and with that concludes the presentation, and then also more or less the meetup, unless there are any questions. I did not see if there were any so far. Okay, I don't see any questions in the chat. Okay, cool. Then I want to thank everybody very, very much. Especially thank you, Patrick. That was a fantastic presentation. And then I hope everybody has a great rest of your day. And then we will see you next time. Thank you very much. Bye-bye.